If you're looking to make your Comet pre-processing a little bit easier and maybe create a time lapse automatically, then this video is for you. The comets we've been talking about for the last couple of months are mostly gone, but hopefully this script helps you reprocess those comets as well as process future comets. This is a Comet pre-processing script, heavy emphasis on the word pre-processing because it will not stack your Comet for you, but it will get you most of the way there, which includes automatically converting all of your files, doing a star registration, star removal with starnet if chosen, and even a quick auto-stretched time lapse. The remaining manual actions would be to do a Comet stack with the already registered frames, stretch that image, and if you did starnet, star removal, stretch the stars and add those back in, and your image is basically done. And you're free to do further post-processing on your images if you choose. This video is a little bit long, but there are chapters so you can bounce around. The beginning part is installing starnet, ffmpeg, and the Siril script itself. If you're comfortable doing those without a guide, feel free to skip the chapter and grab the links from the description below and follow them yourself. I am not planning on submitting this script for official Siril inclusion at this time, or maybe ever. And if you want to support the work that I do, consider checking me out on Patreon and on Buy Me a Coffee. Now let's get to the tutorial. All right, before we get started with the script, we have some setup that we need to do. So first, we want to make sure that starnet++ is available, and it is linked to from Siril. So you'd go to Preferences, go to or Menu Preferences, you go down to Miscellaneous, and then here you'll see this option called starnet++ must point to a valid starnet executable. And if you need to download it, all you need to do is go to the website starnetastro.com/download, and there are a bunch of download links here for Windows, Mac, and Linux. You get the Windows Starless CLI win.zip. I'll show you what that looks like. And when you're here, if you're on Windows, so you have two options. There's also a GUI, which is a graphical user interface, and the CLI, which is a command line interface. This is the one you want to grab. And then after you download it and you extract it, in the folder, I have my starnet CLI win here. It's inside a couple other folders. You'll get something that looks like this, which will include the starnet++.exe, which is the CLI application. You'll have a weights file. It should be in the same directory as this, as well as a TensorFlow, which will use your GPU if you have CUDA enabled. And once you have this, you'll copy this path. It'll be the same thing in Mac and Linux. Just find wherever you installed it. You'd go to Siril, click this. You'd find the Siril, the location here. You click this and you click on open, and it'll load for you. So it must point to a valid starnet executable, and the script that we'll be using today will look for it. So you'll click on apply. There we go. Okay, so now if you want to do a time lapse, we need to install one more thing. It's a software called ffmpeg or ffmpeg. And to get that, you'd go to ffmpeg.org/download.html. We have packages available for all of the major operating systems. I'll be using Windows. And to get the executable file, you hover over this, you'll get these options. You can pick any one of these. The first one is guyan.dev. You open this up and you scroll down, and there are a couple of builds that you can get. So these are the release builds down here. And you have a few options, 7z and .zip. 7z, as you can see, that it is much smaller. And you have a couple of options. You have the release essentials and the release full. You don't need the full version for this, so I'm just going to get the essentials version because we don't need it. All right, that downloaded, and I put it in this folder called ffmpeg comet, and it is .7z, so you do need 7-zip to extract it. So I have it here, 7-zip. I'll do extract 2. And it's in. It opened in my other monitor, but it extracted pretty quickly. I go in here, and then I go into my bin, and this has the ffmpeg.exe, and this is the path we'll need when we are installing things. A more advanced option would be to install this in the path. I'm not going to show you how to do that here. If you do that here, then you don't need the full path. You just need the ffmpeg command, and it'll do things for you. Okay, so we have that here. So now the next thing to do is to install the script itself. So unlike the other scripts that I have, the other pre-processing scripts, these are not official Siril scripts, so they will not be in the get scripts options here, so you can't search for this and it will not appear here. So you have to install it manually, and to do this you have to place it in one of the script storage directories. I already have 2 set, but just for fun for today I'm going to show you that you can create another one and place your script in there. So I created a directory here called custom Siril scripts in my H drive, right? So I'm going to copy this over, copy the file, the directory name over here, the whole full path, and then I'll paste it here. So I have H and astronomy / custom Siril scripts. All right, I'll click on rescan. Nothing's going to happen because there's no scripts there. So I'll click on apply. Now we're going to download the script. So we're going to go to my GitHub, and the GitHub is github.com/nastronaut/Siril scripts. The branch I'm on now is version 2.1.0. This may be different when you watch the video, so please look in the description below for the most up-to-date version of this script. So right now is version 2.1.0. And you'll see a bunch of scripts here. I have Comet PP, I have the OSC PP, and then the Smart Telescope PP. I would recommend checking out the OSC PP and the Smart Telescope PP if you haven't yet already. They are official scripts and you can install them directly through Siril. The SSF scripts I have stopped supporting because the Python scripts can do all of this and more. They'll be removed from this repository at some point soon. So we'll go to cometpp.py. And you're going to click on this little download button on the top right hand side. It says raw, and then this copy raw file, and then download raw file. So you click on this. If your browser prompts you where to save it, you can save it. For me, this is my second time downloading this, and it saved it in my downloads folder. So what I'm going to do is, I cut and pasted the script from my downloads folder here. So now that this is in custom Siril scripts. So if I go to Siril now, go to scripts, get scripts, and I click on this reload button, press apply. You'll see that now if I go to scripts, Python scripts, there's now a new path here called custom Siril scripts because that's the name of the folder that I added, and now I have an astronomy comet pp.py. So now I click on this and it will start up the Python script. If this is the first time you're using this, it may take a little while to install all the dependencies, so give it a minute or two. But if it doesn't load over and over again, let me know. Let me know what the logs are. Send me the log file. So to get the log files down here, you'll click on this little download button. It says export the log. It'll give you a .log file. Send that to me and I can take a look and see what's happening. So I'll quickly go over the UI here and then we'll run our script. So I have the current working directory. So yeah, I did forget to mention that. The first thing you should do is set your working directory. And in my Siril Comet script working directory, if we look at that, I have my folder structures here. So I have my lights, which has 50 images of the comet. I have my flats, my darks, and my biases, which are technically my dark flats. I also have this presets. I'll show you what this is. It's the same as my other scripts where you can save your settings from this script into one of these files. And I already have this because I ran this a couple times before. Looking at the script now, from the top to the bottom. So again, we have the working directory. If this doesn't look right, close the script, click on this little home button, and change the current working directory and restart the script. It gives you the starnet location, so it will see what you set your starnet to. If this does not exist, or if it says not set, you will not be able to check this box that says remove stars. It should be disabled for you. And even if it's not for some reason, you click on this, there's no starnet, it will not remove your stars. Then we have the calibration frame set up. So if you have darks, flats, and biases, you can use this. If you don't have them, you don't have to use them. These are optional. You can use one or more or none at all. And this should work for smart telescopes and non-smart telescopes alike. I have cleanup files here. So if you click on this, it will... Actually, I'm going to click on these because I do have these. If you click on cleanup files, it will delete most of the intermediary files, but since this script does not do a Comet stack for you, it will not remove some of the registered frames, which isn't a true cleanup. But again, this is one of the reasons why I'm not submitting this officially to Siril. So you can use this, it'll get rid of some space, but not everything. Background extraction I highly recommend because it will help with star removal later on. And if you're trying to do a time lapse, just because of testing that I've done, I've seen that without background extraction, things just look a little bit weird when they get normalized. The registration, so this does give you a complete star stack. So this registration is, it'll analyze all of your frames, and if things look wonky, it'll filter those out, so those won't make it to the final register frame stack anyway. And there are two filters available: roundness of the stars and the weighted FWHM, which is the weighted full width half maximum of the stars. Next, we have the stacking option. So this is the remove stars. There's nothing much to it. It gives you some tooltip here. It says it'll create a starless underscore sequence, and it will not create a comet stack, but it will create a star stacked image where it'll stack everything and do a starnet on the very last image and give you a stars.fit file, which I'll go over soon. The stacking settings here, this one I went back and forth. This is just for the star stacking settings, not anything else. Again, this will not affect comet stacking because we'll have to do the comet stacking later anyway. And then finally, we have the time-lapse settings. So if you click on this, these become available. And here, the ffmpeg path is what you need to copy. So I'm going back to my ffmpeg directory here, my bin. So I'm going to copy this. And it's going to be the ffmpeg.exe. Just need the whole thing. There we go. And we have the frame rate defaults to 24. I have 50 frames. So I'm actually going to do 10 frames, so it'll give me a 5-second exposure or 5-second time lapse. And we have the quality, which is CRF. 23 is right in the middle. The highest you can do is 51, I believe. Yeah, 51 is the worst, and then 0 is lossless, so it'll create a much bigger file for you. This does not do any kind of cropping, so that's the only other thing to keep in mind. So I'll just set the quality to 15, so lower is better. One thing you'll notice when you do a time lapse is that it needs to auto stretch each of the files. Right now it's kind of clunky where it opens each of the frames, auto stretches them, and then closes the file and saves the file in TIFF, and then it processes them. So you'll see your Siril blinking a couple times, and the more images you have, the longer it'll take. So just something to keep in mind. Going back to the load and save presets. So right now, if I click on save presets, if I open up Siril again, you'll see that it's saved presets to wherever. What happens is that now if I close this, and in my Siril, so here, my presets, I have this folder here. So if I open up the script again, and I click on load presets, you can see that it loaded all of my presets again, so I didn't have to click all those again. If you see things look a little bit weird, like, this is compressed for some reason, like this just expanded a little bit. So this might be something I fixed by the time you open it. So this is pretty resolution dependent. Okay, so once I'm here, I am going to click on run, and then I'll let it do its thing. So there's a limit of 2,000 frames here at the moment. And we'll see what happens from there. If I open up my folder here, we can see that I have my masters created. So it created my biases master, so it'll create darks and flats as well, which you can use later on instead of the other number of files. So it does create master frames for you automatically, and it is doing the processing, so it'll do the PP flats, etc. So I'll let this run for a while, and then we'll come back and see what the results look like. And this is an example of what auto stretching is like. So this is what I actually want to change. So I'm actually opening these because there's no command line to do an auto stretch on a whole sequence at the moment. So I'm opening the files one by one and then doing an auto stretch. It takes about 1 second to 2 seconds per image. Not that bad if you have 50 frames, but if somebody's coming in from a C-Star who's going to be doing 100 frames, that could be problematic. Or someone coming from C-Stars doing thousands of frames, that could be a little problematic. So something to keep in mind for sure. And now this is going to do a starnet removal from this. I'm just going to switch this to auto stretch so we can kind of see what's happening. And it takes about 30 seconds to a minute per frame. So I have 50 frames. It's going to do them all. It's going to take a little while. So it looks like it already got rid of one in in the filtering process, it was 49 frames. It'll take 49 minutes to do this, so we'll come back. All right, the script finished. Took a little while because of starnet, and this is the final output that we get. So we're actually not even going to use this because we extracted the stars. If I look at the process directory now, I do have my lights fits and my starless lights fits. So starless lights fits is what loaded at the end of the stack, and the star mask that came out of it is what the stars.fits file is. So you can keep it as is for now, but one other workflow that you can follow is, so I'm just going to open the lights.fits file, which is before starnet happens on this image. So if I go to auto stretch, so this is before starnet happens. So we see the stars, the colors look kind of good. This is the smudged comet. We don't really care about it. We don't really want it. But what you can do here is you can solve this, and then we can do SPCC on it to make sure that the colors of the stars look a little bit better later on. So that's actually what I'm going to do now, because I think that's a more appropriate workflow for a lot of people. So I'm going to go to Tools, Astrometry. I'm going to do Image Plate Solver. Most important parts of this page is the focal length and the pixel size of your camera. If you don't have, if Siril Solver is not finding, it's not able to solve for you, you can actually switch to localastrometry.net. There are videos you can follow, especially from my friend Rich at Deep Space Astro, who has information on how to set this up. And this will help you do blind solving by ignoring position and ignoring sampling. But I'm just going to use Siril Solver. It's easier. It's going to use my local Gaia catalog, and it'll solve pretty quickly. I'm also going to turn off flip image if needed, because my Comet image isn't going to be flipped. So I'm going to click on OK. There you go. It's solved. And now I'm going to go to Image Processing, Color Calibration, SPCC. So you need to solve your image in order for the SPCC to be active. I'm going to click on this. I have my OSC sensor, so it's my Sony IMX571. Find your sensor, the closest one that you can find. It's a one-shot color, not narrowband. I'm just going to do average spiral galaxy, and it has the base UV IR block filter. And then I'll click on OK. And in my other screen, it opened up the white balance summary of the RG and the BNG, and we can see that it did its best to give me some more accurate star colors. Great. So I can close this now. And now I can run StarNet on this and get rid of the stars for use later. So I'm just going to do image processing, StarNet, star removal, generate star mask. This is what I want. I want the star mask. And I don't need to apply the sequence. This is not a sequence. And then click on execute. All right, that took about a minute, almost a minute, 59 seconds, and it gave me my starless lights.fits, which I don't care about right now. And it has my, if I refresh this, I have my star. Where's my star mask? Oh yeah, star mask is going to be in my working directory because that's where I put it. So it'll be my star mask lights here. I'll open this. There we go. It's auto stretched, so the colors, it looks a little bit weird, but the colors are going to be a little bit better when we combine them later on. So I'm just going to leave it as is, star mask.lights. If you want to rename this, you can. I'm just not going to. So the next step, what we need to do is we need to change our working directory to the process directory because it has the sequences that we need access to. So we'll click on open. I'll go to my sequences tab up here, and then I'll click on search sequences. And there's just two sequences because we did cleanup files, and it cleaned up every other sequences that we don't need. So we have the R_BKG lights, which has the registered background extracted lights. So we can look at these. It's registered on the stars. And we have the starless RBKG lights, which is the starless versions of all of this. And this is what we're going to use to... There's 48 of these. Okay, so this is what we're going to use to stack on the Comet. So we're going to make sure that we're on the starless sequence. Go to registration. Make sure Comet asteroid registration is selected. We're going to click on our frames list at the bottom right-hand side here. Make sure our first frame is selected. I'll close this for now. I'll zoom in with my scroll bar. I'll make a tiny box around the core of the Comet and click this box that says pick object in number 1. So it gets the pixel coordinates. I'll click back on the image frames list again. Go all the way to the bottom, click on my 48 48th frame, 49th frame. Yeah, I guess I got rid of something in the middle. It's probably going to be number 31, yeah. Okay, so I have that. I'm going to just click and drag the box here. I don't need to create another one over the coma, and then click on Pick Object in number 2, and it gives me a delta x and delta y, which is the change in the x and y coordinates from the first frame to the last frame. And then once we have this, we're going to click on Go Register. And this is pretty quick. It takes like a second. And then we'll go to our sequence. We now have a new sequence called Comet Starless on R_BKG. And if you open our frames list again, we'll see the x and y coordinates here. You can see that they have these images have the blue border around the comet, around the frame, and it is all registered. But we're not done yet because we need to apply the registration. So we're going to go to Registration tab again, change the registration method to apply existing registration. For the image selection, we're going to make sure it's all. The framing method will be current. We don't want to do maximum or minimum or anything. Keep it at current. It'll make things combining with the starless image or the stars image a little bit easier. You can click on estimate, you don't need to. And then we're going to click on Go Register, and it'll create a new sequence with R_. So this takes about a minute or so. Finish took a couple of minutes actually. And now if you go to our Sequences tab, we'll see a new sequence called R_. So there's lots of R_ sequences here, but we want the R_Comet_Starless. This is our Starless. This is what we're going to stack on. And now we need to stack this. And we're going to go to our Stacking tab. And we're going to just keep everything basic for now. So average stacking with rejection, additive with scaling. Pixel rejection is something that you could experiment with. I will recommend starting with Winsorized Sigma clipping. I can do a more in-depth video on what all these pixel rejection algorithms do if there's any interest. But Winsorized Sigma clipping is one of the safer ones to do, where it will get rid of some of the star streaks or most of the star streaks, but also make sure it doesn't get rid of a lot of the tail detail. If you see that you have a lot of star streaks even after doing starnet, which you'll actually see with this image, you can play with the sigma low and the sigma high. So the lower the number for both sigma low and sigma high, the more aggressive the clipping will be. So if you see lots of star streaks, you can lower this, but a warning, if you lower this, you may also end up losing tail detail. If I zoom out, you can see the tail in this single 30-second image goes quite far, so you could end up losing some of that data. It's a trade-off. More aggressive pixel rejection could be sigma clipping. You could try that out too. And even more aggressive is mad clipping and linear fit clipping. So try those out as well if you're seeing lots of star streaks in your stacked image. So I have this here. In the stacking results, I'm going to click RGB equalization and then save in. I'm just going to name it Comet Stack and click on Start Stacking. All right, that took less than a minute to do. And if we look here, you can see Comet looks amazing. There are some star streaks here, but they're actually not too bad at all. So I have no problem stacking this. So now I have my Comet stack. If I look at my directory here in my process directory, so now I have a Comet stack here. So I'm just going to copy and paste this here. So now I have a Comet stack and my starless or star mask lights. So if you wanted to, you can end the processing here, combine the stars with the comet pretty easily by going to image processing, star recomposition, close the current image. And now I'm going to open my Comet stack and my star mask. Didn't open. There we go. Just took a while. And then you can just call it a day. But we can do a little bit better, I think. So I'm just going to click close this. And so what I'm going to do now is I'm going to go to the conversion tab and actually bring in my Comet stack and my star mask lights. I'm going to create a sequence out of them. And I'm going to change my working directory back to my Siril Comet scripts directory, just going up one. So there we go. My home directory has changed. I have my comets, and I'm going to name this, Comet Stars Sequence. It'll do a symbolic link. We convert. Great. Now if you look at our sequence, there's only one sequence here, and there's 2 frames. First one is going to be the comet, the second one is going to be the stars. So the first thing we want to do is we're going to quickly do a crop. I don't want to get, is it just to get rid of the edge artifacts basically? I'm going to right click, crop sequence, and it'll output a prefix of a cropped. Alright, so now we have our cropped comet and stars. If you look at our second frame, it has our stars here. Great. And you can just keep it as is and then merge these and then do the star processing here if you want to, but I'm going to stack these separately using statistical stretch. So this is another script that you need, which is Python scripts processing statistical stretch. You can find this in the Get Scripts repository. But before I click on that, I need to open these images individually and not as part of the sequence. So I'm going to click on open, and I'm going to find, so these are my two images here. So you can see that the comet is here and then the stars is here. So I'm going to do my comet first. Click on open, go to scripts, Python scripts, processing statistical stretch. And before I forget, I want to make sure that my viewer is in linear mode and not auto stretch so that I can see my changes. I want to keep the target median at 20.20, just the default. I'll do a link stretch, normalize, and I'll also do an apply curves adjustment. I'll also set that to 0.20 and click apply. That's actually pretty good, right? It's a pretty nice comet right out of the get-go. I probably could have done a little bit more of the target median, so I'll actually press undo here, go back here, and then increase this to 0.25, click apply, just to make it a little bit brighter, and I think I'm actually pretty happy with this. So I'm going to close this, I'm going to click on save, so now my cropped comet is now stretched. I'll click on open, I'll open my second file, which is the stars, click open, I'm going to do a processing statistical stretch once more, and then here I'll make the target median maybe like 0.3. I won't do a link stretch, and I'll do an apply curves adjustment. This is going to be a pretty aggressive curve because I want the lights to be light. Click on apply. There you go. That looks actually pretty good, right? The stars look okay, colors look okay. It's a little bit red, so actually maybe if I undo this and then I click on linked stretch, there you go. That makes the colors a little bit better, right? So I have some reds, some whites, some blues, some greens here, which is okay. Okay, so I think this is okay. All right, so I'll click on save. Great, so now I have my two images done. And now I want to combine them, so I'll go to image processing, star recomposition, close the current image, yes. For my background stretch parameters, I want to make sure it's my comet image, so it's going to be cropped comet stars 1. There it is. And then for my star stretch, it'll be my cropped comet stars 2. There you go. That looks pretty good, I think. And then if this is a little bit too bright for you, you can change the black point on the star stretch. You can see that it's stretched quite a bit here. You want to move the black point over a little bit. So there you go. And we don't do too much. We don't want to start clipping. Oops. There we go. I think this is okay. You can also move the black point of this here. There we go. All right, apply, close. And this is my final results. The comet head looks good. The colors look good. The stars look good. The star trails could probably be better, but it's okay. We can deal with it later on if we need to. The tail looks amazing. And now I'm ready to save this as, I'll do final comet stack. Save it as fits, and this is our final data. So not bad, right? This is pretty good. All right, now let's talk about the fun thing, which is the time-lapse processing that it does automatically. So in my time-lapse images directory, which is created automatically, the script will automatically auto stretch and export each of these as a TIFF file, so the frames get saved. So if you want to process these later on yourself, you can. It doesn't do any other kind of processing on it. This is just as is. And we have all 49 or 48 frames in here, and it creates an MP4 file using whatever quality estimator that you picked. So I'm going to double click this and play it. It's a giant file, so my computer's had issues playing with it, but you can see that here it goes. I'm going to change the speed to 5x because it's about a little over 3 seconds I did the whole animation thing just for fun, just for myself, but you can actually go into the sequences tab here, and there's a sequence export section here. So you can actually load a sequence and then export them as like an AVI or a SIR file or an MP4 or a WebM file, all through Siril. I could do that too, but since I was automating a lot of this anyway, I wanted to see if I could automate that part as well, and luckily it worked. As I mentioned earlier, I do want to stretch the images a little bit differently, but for now, I'm happy with what this gets. And this is also a really good way to know that I probably should have discarded this frame because there's a cloud going through here. Probably messed with some of my colors, but whatever. I hope this was useful. There was a lot of information, but I have a tiny bit more for you. This script does not plate solve, and it will not do mosaics or multi-night because comets move too quickly through space anyway, so you don't want to do multi-night imaging at all. But this also means that the script should work with whatever telescope and camera you use, whether it's a C-Star or a DSLR. I would love feedback from you about the script. If you have any questions, do let me know in the comments below. If you have suggestions for improvements, I'd love to hear them as well. If you've taken images and you want to share them, consider joining our Discord server where we have a growing community of astronomers and astrophotographers, and we would love to have you. Thank you for watching and bearing with me through this long video.